Welcome to our discussion on right triangle trigonometry. As always, feel free to fast forward to the section that covers what you think you need to review. Let's start off with some definitions. When we're talking about trigonometric ratios, we're just talking about the fact that given any angle, right, less than 90, greater than 0, basically an angle in a right triangle. If you have a right angle, the other two angles we know have to add up to 90, right? Because the three angles have to add up to 180. So if you want to call this angle A and this angle B and this angle C, we know that A plus B plus C always equals 180 degrees. That's the rule for any triangle, right? And then of course when we have a right angle, we know that's always 90. So if this is 90, then by simple math we know A plus B equals 90. And since the angle has to have some measurement, it can't be 0, right? Because a 0 angle would just be, two lines sitting on top of each other. Then the other angle has to be between 0 and 90. Okay, this is just a way of describing a right triangle. Once we have a right triangle, we're going to designate one of those angles as theta. This is the Greek letter theta. And once we designate that angle, then this side here becomes opposite, right? See how it's opposite of that angle? And then B becomes adjacent. It's attached, right? These two sides make up that angle. And then of course C is always the hypotenuse, because it doesn't matter which angle we use, either B or A, C is still the hypotenuse. Okay, so just a little definition. Now, just about everything you need to know from this lesson can be broken down to SOHCAHTOA. Sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. SOHCAHTOA. SOHCAHTOA. Easy way, hopefully, to memorize these relationships. Also, I think it helps to always draw a picture. As you're trying to memorize these things, constantly draw this picture for you. And it just helps you to remember. C is your hypotenuse, right? A is over here, B is here, and then you get the A's, B's, and C's. Now if you put the A and the B in the wrong place, it doesn't matter, because this only matters if you have memorized all of these things, and it's really not necessary to memorize these, right? So don't bother. What's more appropriate or easier is when you're thinking of this angle, remember that this triangle is really coming from our unit circle and the x-axis and some angle theta, and it creates this right triangle, right, with the point there on the circle. And if you can relate it back to the unit circle, you know that the vertical distance is always sine, right, and the horizontal distance is cosine. That's how we define these things. Sine is the vertical distance, cosine is the horizontal distance. So when we have this point and we have the coordinates of the point, right, it's basically cosine sine, right, x and y. Cosine is your x, sine is your y. Well, if you look at this triangle, it's just this triangle that's been moved outside of the circle. And so if we're taking sine of this angle, we know that gives us the height, right? And originally the answer was sine was just this distance, right? But that's because when we're on the unit circle, the radius is 1. Technically, what we should have been saying from day one is that this height is not sine, it's the ratio of this height divided by the radius. But because the radius is 1, it ends up being just the height. And that's why sine of theta is opposite over hypotenuse, right? In the unit circle case, it's opposite over 1, and it ends up just being that height. But in the more generic case, meaning C no longer has to equal 1, it can be any length we want, right? We can make this triangle as big or as small as we want. Sine still measures this vertical distance, but it's the ratio of the vertical distance over the hypotenuse. And then cosine, instead of being just this distance, this horizontal distance, it's that distance over the hypotenuse. In this case it's 1, right, which is why we just get that length. But in the general case, it's adjacent over hypotenuse. Okay, and then we know that tangent was always sine over cosine. This distance over this distance over that distance, or more generally, it's really this whole fraction over this whole fraction. But when you have a fraction over a fraction and they have a common denominator, you multiply top and bottom by c to get rid of those common denominators, and it reduces down to just a over b. Yay, that's where they all come from. And then once we have these three, the other three, right, just come from those definitions, because cosecant is defined as just 1 over sine, so we just flip the fraction. Secant's 1 over cosine, so again we flip the fraction. And of course cotangent's 1 over tangent, so we flip that fraction. So these three over here we get for free, right? All we have to do is remember these three over here, which comes back to the triangle and comes back to SOHCAHTOA. So once you have SOHCAHTOA in the triangle, you're good to go. The rest of all of this is just going to be kind of applying that knowledge. Here's a simple example. If we want to find the exact values of all 6 trig functions given a particular angle or some sides, or basically some descriptions of a particular triangle. There's our triangle. They gave us 2 sides. We know we can solve for the third side using Pythagorean theorem. We get that third distance of 4. And now, if we remember SOHCAHTOA, we know that sine of theta is opposite over hypotenuse. So sine is going to be 3 over 4. Cosine is going to be square root of 7 over 4, right, because it's adjacent over hypotenuse. Tangent is going to be opposite over adjacent. So it's going to be 3 over square root of 7, but they most likely don't want us to write it that way. So we would rationalize the denominator, right, by multiplying both sides, or sorry, top and bottom by square root of 7, and we would get 3 root 7 over 7. And then from here, it's just the other 3 are 1 over. Here we all have them on one slide. You can check your work, but hopefully that was relatively simple for you. The next concept is evaluating different trig functions. We can find the other 5 trig functions given some angle theta, given that sine of theta equals 2/5. We've seen these types of questions before. We know that if sine of theta gives us 2/5 and sine of theta is opposite over hypotenuse, then we draw our triangle and label it opposite over hypotenuse. There's the 2, there's the 5. We can solve for b with Pythagorean theorem. Right, and this is where most people make mistakes, is solving for the third side. You just have to remember that it's always a squared plus b squared equals c squared, and c is always the hypotenuse, right? It doesn't matter about a and b, just as long as c is the hypotenuse. Plug in what we know here. 2 squared plus b squared equals 5 squared. 4 plus b squared equals 25. Subtract the 4. B squared equals 21. B equals plus and minus the square root of 21. But because we're dealing with distances, we're most likely only going to take the positive version, right? It's just going to be square root of 21, which is what they did here. Now that we have all 3 sides, we can solve for all 6 of our trig functions very simply by just doing SOHCAHTOA again. And there they all are. Okay, complementary angles, not used a lot, not very helpful. I wouldn't waste a lot of brain power trying to memorize them. It is kind of interesting, and it is kind of helpful in some cases, but they're very limited and very specialized. More than anything, it's just, I think, kind of interesting to note that all of these functions kind of match up with each other once you rotate 90 degrees. You go 90 degrees and all of a sudden sine goes to cosine, tangent goes to cotangent, secant goes to cosecant, and so on and so on. But as far as applying it, it's pretty limited, right? Because being able to calculate things is only going to work if you're given something and then asked for something else that's exactly 90 off from it. So it's kind of a silly, kind of stupid thing. There might be a homework question here or there, one or two, but for the most part, you can skip this kind of stuff. Well, I shouldn't say skip. You don't have to really spend a lot of time memorizing this stuff. Okay, but solving right triangles, much more helpful. You're going to see a lot of applications and word problems that deal with right triangles. In physics, especially, you'll see them all the time. And then in calculus, you'll see them. So make sure you get good with SOHCAHTOA and creating a right triangle and being able to solve for all the missing pieces. And what I mean by that is we know that all three angles add to 90. So if they give us one, we can very easily solve for the other. Because we know angle B here has to be 90 minus 23, right? 90 minus 23 gives us a 57. So we know this is a 57-degree angle. That might be helpful. Given a length and an angle, we can solve for a lot of things. If we're trying to figure out what A is, well, we know that sine of 23 has to equal A over 5.8, right? Opposite over hypotenuse. And now we know if we multiply both sides by 5.8, this is how they got to there. And then if you just stick that in your calculator, that's where you get 2.3. Of course, you can do the same trigonometric trick for getting B using cosine, right? Cosine of 23 is going to equal B over 5.8, sorry, which means 5.8 cosine 23 equals B. Plug that in your calculator and be done. But you could also do it with Pythagoras theorem, right? 2.3 squared plus B squared is going to equal 5.8 squared and solve it that way. I honestly think this way is easier and cleaner than having to deal with the Pythagorean theorem. And that's what we did on this slide. Okay, another situation. What if we're given two sides? Well, we can obviously solve for the third with Pythagorean theorem, but we can also solve for angles using our inverse trig functions. We know that if we're trying to find angle A, for instance, right, the angle down here, we're trying to find this theta, that tangent gives us opposite over adjacent. Tangent of A equals 9.5 over 3.4. To solve for A, we just take inverse tangent of both sides, right? But remember, we're not multiplying by inverse tangent, we're applying inverse tangent to it. Inverse tangent is a function. We're applying that function to both sides. And when we apply it to the left-hand side, the inverse, right, they undo each other, and that's why you get just A. And on the right-hand side, we have the inverse tangent of this, which we can again just plug into our calculator and get an answer. Okay, we already talked about how we can find C with Pythagorean theorem. Let's move on to looking at some of these as applications. The dreaded word problems, right? Don't fear word problems. They're actually easier than regular problems because they put the information into context. If we want to determine the height of a cloud at night, a farmer can shine a spotlight upward to a spot on the cloud. The angle of elevation to the same spot on the cloud from a point located 150 feet horizontally from the spotlight is 68.2 degrees. Find the height of the cloud. You're probably thinking, this is the dumbest thing I've ever heard. Why would we ever do this? Well, in real life, nobody cares how high a cloud is. But it's just a thought process, right? We're just trying to figure out how we could think our way through some things. We could still apply this to something else if it wasn't a cloud. But you get your angle, right? We know that tangent of that angle is going to give us opposite over adjacent, and we know that adjacent is 150, right? Because we moved 150 feet over and then looked up at that same spot on the cloud and went, oh, that's 68.2 degrees. And from doing that, we can figure out that the cloud is roughly 375 feet up. Okay, if we want to measure the height of Mount Kilimanjaro by using the height of a nearby mountain, here's our picture. If you're standing on the top of that other mountain, you know how tall you are at that point, right? You know you're at 8720 feet. You have an angle of what's called an angle of inclination. So the angle up from the horizon so that you're looking at the top of Mount Kilimanjaro is 23.75. And if we know the distance, right, we have some sort of measurement of that distance, so we have the measurement of the hypotenuse, we can now solve for h. Which trig function would we use? Given all of these pieces of information, right, we have the hypotenuse, an angle, and we're trying to find h. Which trig function relates those three things? And hopefully you're saying sine. Sine of 23.75 equals opposite, right? This is opposite. I know it's confusing because it's an h, but it's opposite over hypotenuse, 4.9941. Multiply both sides by 4.9941 to solve for h. Don't forget you're going to have to add 8720 to it to find the actual total height of Mount Kilimanjaro. That's what we did here. We got the 2.0014 as h. Converted that to feet. Added the 8720 that we were already standing at and got a total of a little over 19,000 feet. Okay, you can see that word problems, the hardest part about a word problem is going to be drawing the picture. To find the width of a river, a surveyor sights a straight line straight across the river from point A on their side to a point B on the opposite side. Okay, so let's draw that picture. Here's the river. If we go from this point straight across to this point, right, that's B, this is A, right, point A on our side. Then we walk 200 feet upstream, so we walk over here to this point C, and this is a distance of 200 feet. And then we sight that same spot, excuse my horribly not straight line, and we figure out that this angle here, theta, is 58 degrees. Now they want to know how wide is the river, so aren't they asking us to solve for this length here? That's a right triangle, right? Because remember we sighted straight across, so at a perpendicular angle. And now which trig function would relate x to our known piece of information here? And hopefully you're all screaming at me, it's tangent, dummy. Yes, it is. Tangent of 58 is opposite over adjacent, or 200 tan 58 equals x. There's a much prettier picture. There's the same setup and the answer of roughly 320 feet. Okay, one last example. Security camera 40 feet away from the counter. Counter's 30 feet long. What angle to the nearest degree should the camera rotate through so that it scans the entire counter? Well, we can break that in half and look at two different triangles. The triangle on the right, and we look at just that piece, we get this distance of 15 feet. We're still 40 feet away, and now we have some angle theta that's just this distance here, not the whole thing. Well, if we want to solve for that angle, which trig function will relate this angle to the two pieces we have? And lo and behold, it's tangent again, right? Tangent of theta is opposite over adjacent. So theta is inverse tangent of 15 over 40. You can reduce this if you want, right? 15 over 40. Obviously, if you divide top and bottom by 5, you get 3/8. You get the same answer either way when you do inverse tangent of it. That's going to give us this theta, and then all we have to do is double it to get the entire thing. Let's see what they did, right? There's the picture. It's talking about how we're looking for half the angle. We're doing the inverse tangent of 3/8. We get that 20.556. We know we have to double it, and there's our 41-degree angle. Okay, guys, that's it. It's all about SOHCAHTOA, right? It all comes down to this, SOHCAHTOA, that simple triangle, and knowing the ratios of all of the information when we're dealing with a right triangle.